All right, here's the answers to the radical functions review worksheet that you guys got yesterday. And I just wanted to throw this up here and go through a couple of these, see if I'll answer any questions that you might have had. Make sure you're ready to go on your quiz. So remember, when you're graphing these things, square roots follow that same pattern where we start here and we go over 1, up 1, and then over 4, up 2. And remember, that's reversed from our parabola. The pattern for the parabola was over 1, up 1, over 2, up 4, and we just flip-flop all those. So for radicals, it's over 1, up 1 for square roots, really. It's over 1, up 1, over 4, up 2. So when I look at this first one's going to follow that standard pattern, except it's going to open down because of the negative, and it's going to move to the right 3 because that minus 3. So the vertex is now at 3, 0, and it's going to open down but use that standard shape, okay? And that's how I get the graph that I came up with over here. The next one, same thing, it's that standard graph, but it's been shifted. Notice again the A value is 1, so the A value is telling us that it's going to open up. It's going to be our standard shape, but it's going to be moved to the left 1 and down 2, so the new vertex is negative 1, negative 2, and there it is, okay? I still follow the same pattern, over 1, up 1, over 4, up 2. Number 3, for a cubed function, remember cubed functions fall into this format. We start at 0, 0. It's over 1, up 1, over 2, up 8. Okay, so we're cubing each piece. Same thing in the other direction. Back 1, down 1, back 2, down 8. All right, and if I were to go over 3, I'd be up 27 and down 27, so it follows this pattern. But now what happens with this one, since I have a negative out front, I'm basically going to flip this thing upside down. So this piece over here that was opening up is now going to open down, and this piece that was opening down is now going to open up. All right, that's the effect that changing the A value has. And so we come up with this graph that's the same size and same shape, but it's opening in a different direction. Okay. Next one, it's our square root function, but it's going to be moved down 4 because of this minus 4, so it's going to be down 4. So the vertex is like 0, negative 4. And now this one's going to open to the left because the negative inside, okay? When I change the leading coefficient of x on the inside, that's going to reflect us over the y-axis, so it's going to flip us left and right. So this one opens to the left instead, but it still has that same shape, over 1, up 1, over 4, up 2. Okay. Number 5 is really just about understanding that this thing means the cube root. So keep in mind the 1/3 power is the cube root of x. And a cube root function is the same as the cubed function, so it's the same as essentially the function we have above, but turned kind of on its side because it's the inverse. We're flipping all the ordered pairs. So notice it follows that same pattern in reverse, over 1, up 1, over 8, up 2. Okay, so it's the same pattern in reverse, and this is just our standard graph of what the cube root function looks like. The next one, if we see what the cube root function looks like, this one should be pretty simple. It's going to be just like the cube root function that we just graphed in number 5, but it's going to be moved to the left 1 and down 3. All right, so the new vertex, quote unquote, because there's not really a vertex on this one, is at negative 1, negative 3. Okay, it's kind of the center of this thing will be at negative 1, negative 3. All right, but then we follow the same pattern from there, over 1, up 1, over 8, up 2, and that's it. As far as solving these things go, the first couple should be pretty straightforward. I just have one radical symbol, so remember you got to isolate the radical. So like the first one, I add the 6 to isolate the radical, then I undo the radical by squaring each side, then I solve what's left. Okay, and make sure you plug these back in and make sure that they work. Like I plugged the 105 in and it does work, so make sure you're doing that as well. The next one, again, pretty straightforward. Isolate the radical. I got to subtract the 5, then I divide by the 2. Then I undo the radical by squaring each side, and then solve what's left. And really, we're just working backwards through order of operations. We undo addition and subtraction, then we undo multiplication and division, then we undo roots and exponents, then we undo parentheses. And the thing that's under the radical, it's assumed that it's in parentheses, and that's why we do it last. But again, make sure you plug this back in and make sure that works, and that one does. Okay? Number 9, again, straightforward. Add the 7, divide by the 2. But now this one's a cube root function this time, and apparently, I don't know what happened here. Apparently I didn't finish solving this one. So let me do that right now. That's going to leave me with a cube root of 9x equals a 3. Or maybe I did and the ink got sent all over the place. That happens sometimes. So now from here I want to, instead, because this is a cube root, I have to cube each side instead of just squaring it. All right, And when I do that, it leaves me with a 9x equals 27. And now I'm going to divide each side by the 9. So I find out that x equals 3. But again, plug it back in, make sure it works. I plug the 3 in, and it looks like it is going to work. Okay? So make sure you're plugging these back in. Check for extraneous solutions. The next one, number 10, you notice I stopped halfway through the problem because I recognize after I subtract the 4, I get the 4th root of x minus 2 equals a negative 7. And with an even root like that, I can't find a value that's going to give me a negative, okay? If it was an odd root, if it was a cube root can equal a negative, a 5th root can equal a negative, but a 4th root, a square root, a 6th root, those even roots can't equal negative, so it's going to be no solution. And if we were to raise each side of the 4th power and add the 2 over, you're going to come up with an answer, but that answer is not going to work when you plug it back in, so just be aware of that. Make sure you're plugging the answers in, because if you went through and got the answer on this one, you'd find out that it's not going to work, okay? Number 11, 11 through 13, these are where it gets a little bit tricky in terms of trying to solve these things because I have multiple radicals. So remember, you want to isolate one radical at a time, all right? Always isolate the bigger radical first. It just makes things a little bit easier when you do that, okay? So like in this first one, I want to isolate the square root of x minus 8 first because it's larger, okay? So I isolate the square root of x minus 8 by subtracting the 2. And now I've got that thing by itself. I square each side, and just be careful right here. Looks like I didn't finish solving this one either. But be careful when you're doing this guy. Let me take this off to the side. The 2 minus root x squared. You have to multiply this thing by itself, so you have to FOIL here. That's where I get the 4 minus 2 root x minus 2 root x plus x when I do root x times root x, and then combine like terms. So that's where I'm coming up with that. Those terms that are over there. You have to multiply this thing by itself, and you have to FOIL. That's the part that we tend to forget. So now over here, if I finish solving this guy, I'm going to subtract each of those values. When I do that, that's going to give me a negative 12 equals a negative 4 root x. And now I divide by the negative 4. So this one seems like it's working out okay, but just be careful. Make sure you plug this back in when we're done. That's going to be a 3 equals the square root of x. I'm going to square each side. And it looks like it's going to give me x equals 9. But again, especially with these, because these can be a little bit tricky, make sure you plug them back in and make sure they work. Let me try that again. Keep trying to switch colors. It's not working. There we go. But plug it back in. 9 minus 8 is a 1. Square root of 1 is 1. Plus 2 is a 3. So I get 3 on the first side. On the second side, it looks like I get 4 minus the square root of 9 is 3. And 4 minus 3 is actually a 1. So I got a 3 on the first side and a 1 on the other side. So this one does not work. So since there's no other valid solutions, I'm going to say this one's no solution. Okay? The next one, again, isolate the larger of these two. The large one's already isolated, so I just square each side. Again, when I do that, make sure that you are taking this thing off to the side right here, this guy. Make sure you're taking this off and you're doing 3x minus root, or sorry, 3 minus root x times 3 minus root x. All right, you have to FOIL this thing. That's where I get the 9 minus 3 root x minus 3 root x plus x. And then when I combine like terms, it gives me that 9 minus 6 root x plus x, okay? Make sure you're doing that. If you don't do that, then it's just not going to work out, okay? And then I get everything on the same side. I subtract the 9, subtract the x, leaves me then with a negative 5 equals negative 6 root x, and now I'm going to divide each side by the negative 6. So I find out the square root of x equals a positive 5/6, and now I square each side. And I noticed a couple people in class yesterday were having a little bit of trouble squaring this. Just remember, you just square the numerator and denominator individually. So I get x equals, well, here 5 squared is 25, 6 squared is 36, so I end up with a 25 over 36. Again, plug it back in, make sure it works. When you're doing this in reverse, when you're taking the square root, the first one, you're going to have to get common denominators, which kind of stinks, but the 4 over 36, that's going to be a Let's see, I got to multiply by 36 over 36. So it looks like that one gives me a 144 over 36. And then so underneath here I get this, which is 169 over 36. So I get 169 over 36. When I take the square root of that, because that whole thing's under the square root, I just do each of them individually. The square root of 169 is 13. The square root of 36 is a 6. So I get 13 over 6 on this first side. On the other side, I have 3 minus the square root of 25 over 36, which is essentially going to give me 3 minus, again, take the square root of each individually, that's a 5 over 6. And now, common denominators, this 3 would actually be an 18 over 6. And when I subtract, that looks like it gives me a 13 over 6, which is exactly what I got on the other side. Okay, so make sure you're plugging this back in. Obviously, this one is far more difficult to plug back in than some of the other ones we did. But again, it's manageable. When you see those fractions, you just take the square root of each individually. Okay, so that one works. And then the last one, this one was kind of a challenge problem, a little bit tricky here. Because I have two different radicals, I've got a square root and I've got a cube root. Essentially, I have to square each side and then cube each side, which the equivalent of that is just raising each side to the 6th power, and we talked about that a little bit. When you do that, you end up with, because basically some of this cancels, like here the 2 and the 6 reduce, here the 3 and the 6 reduce. The 2 and the 6 reduce to a 3, the 2 and the the 1/3 and the 6 reduce to a 2. And so what I have is I'm cubing a binomial on one side and I'm squaring a binomial on the other side. And there's two approaches to this. You can either multiply all this out, which is what I did the first time. So I'm multiplying out that cubed and I'm multiplying out the squared. And then I gather everything on the same side, so I come up with this equation. This is a polynomial function, and we solved these a couple different ways. This one can't be factored the way it's written. You can try factoring by grouping. So you do guess and check, you build a bridge, come up with the factors of -24, and then you just start guessing. So over here I took a guess, I guessed 6, so 6 ended up working, and it left me with this guy, the x squared minus 4x plus 4. I can factor that further, so that gives me an x minus 2 and x minus 2, so then I solve that and I get x equals 2. So really I come up with two answers. I come up with the 6 that I found by guessing, and then I came up with the 2 by factoring, so I get two answers here of 2 and 6. The other option, and one of you yesterday was kind of on the right track with this and almost found it this way. Maybe they finished and did find it this way, but the thing you might notice here is when I get down to this form, when I have the cubed binomial and the squared binomial, right here, this one has a factor of 2. So if I factor the 2 out, notice it's still in the parentheses here. But now think about when I raise something to power, like when I have 4x raised to the 2nd power, I just square each piece individually, so I get 16 and I get an x squared. It's the same thing here. I have these two pieces. I just square each of them individually. So I do the 2 squared is 4. The x minus 2 squared is x minus 2 squared. And so now what I did was I subtracted that to the other side, and now I have a common factor. See how I have these x minus 2's in common? In fact, there's an x minus 2 squared in common, so I factored out the x minus 2. When I do that, when I take an x minus 2 out of this first piece right here, it leaves me with just one x minus 2. So if I take two of those away, it leaves me with one x minus 2. Out of the second piece, if I take away the x minus 2 squared, it just leaves me with a minus 4. And so I get x minus 2 minus 4 left in my parentheses when I factor that out, which is a little bit confusing because I'm factoring out a big chunk. But then I combine like terms, and it leaves me with the factors of x minus 2 squared and the x minus 6. And then I just set each factor equals 0, and I find out that x equals 2 and x equals 6. Okay? So just another way to do it. Again, that was a challenging problem. I won't necessarily give you one like that on the quiz. So good luck. If you have any questions, you can try asking me, but I probably won't hear you. So maybe ask a friend, a smart friend. Okay?